Hi, my name is JBlockey, and I'm here to talk to you about ionic bonds. So, what even are ionic bonds, you ask? Well, let me show you. Ionic bonds are bonds that connect to nonmetals and metals through transfer of valence electrons. So here you can see a metal and a nonmetal, as indicated by the illustration. And during ionic bonding, the nonmetal transfers one of its valence electrons. You can see, transfers one of its valence electrons, or the metal, sorry, transfers one of its valence electrons to the nonmetal, and they form a bond. So, here are the steps for ionic bonding. As long as you know these steps, you should always know what someone's talking about, what is going on when someone mentions ionic bonding. So the first step is that it starts with two separate atoms. So here you can see there's a separate sodium atom and a separate chlorine atom. Those are the atoms we're going to be using in this compound called sodium chloride, also known as household table salt. Now, the next step is that the sodium gives an electron to the chlorine, or as a more general use, the metal transfers an electron to the nonmetal. Now here you can see the sodium is giving an electron over to the chlorine. That's what happens every single time someone says ionic bonding. You should think giving an electron, donating an electron. The metal is always going to be giving an electron, or more than one electron, to the nonmetal. To the nonmetal. Now the next step is the atoms get a charge and they become ions. So here you can see in the middle of the nucleus it is seen that it just says Na, or sodium, and same for the chlorine, just says Cl, or chlorine. Over here, once the electron has been donated, you can see that there's a little plus sign here, a little minus sign here. That's because they've now become ions. So an ion, all that an ion is just a charged ion, or a charged atom. Any atom that has a charge is called an ion. And you can see, as you know, sodium has 11 protons. It's the 11th element on the periodic table. It has 11 protons, and respectively, 11 electrons if it doesn't have a charge, if it's just a neutral atom. Protons are positively charged, and electrons are negatively charged. So, when sodium becomes an ion, gets that +1 charge, it's because it is giving an electron, and it now has an imbalance of protons and electrons. It has 11 protons and only 10 electrons. It has one more proton. Protons are positively charged, therefore it gets the plus charge. And with chlorine, 17 protons, 18 electrons. Electrons are negatively charged, so it gets that minus charge, -1 charge. And then they become ions. This is a sodium ion. This is a chloride ion. Now, the last step for ionic bonding is that the ions have opposite charges, so they stick together. And that's always how it goes in ionic bonding. It starts with two separate atoms. The metal gives this electron to the nonmetal, and then they become charged and become ions, and they stick together. And this is all to do with electronegativity. You may ask, why does the sodium even give an electron in the first place? Why does it feel the need to do that? Why doesn't it just keep the electron? You might think, I'd want to keep an electron if I was an atom. I ain't giving any of my stuff away. Well, it all has to do with electronegativity. And it sounds like a big, scary word, but you don't have to worry about it. I'm going to explain to you exactly what it is right now. And all electronegativity is the measure of how badly an atom wants an electron, or doesn't want an electron. So you can see here's the sodium ion, or sodium atom, sorry, as illustrated by the diagram, the 11th element in the periodic table, and sodium is a metal. And metals generally are always going to have low electronegativity. Therefore, it doesn't want electrons. And the chlorine here is a nonmetal. And nonmetals generally have high electronegativity. Therefore, they want electrons. Now, there's one more key thing you have to remember for ionic bonds, is that, and it's also the reasoning behind electronegativity, is that in an atom's life, its only purpose is to achieve a full valence shell. Atoms are always looking for a full valence shell. And the valence shell is the valence shell that includes the valence electrons is always the outermost shell in an atom. And so here for sodium, you can see this is the valence shell for a sodium atom, and this is the valence shell for a chlorine atom. Now, when ionic bonding occurs, the sodium, which has a low electronegativity, doesn't want atoms. It wants to give its electron to the chlorine, which wants atoms. And this is because the sodium wants to achieve a full valence shell. And how it can do that, the easiest, most efficient way for it to do that is to get rid of this electron so that this orbital, or this energy level, becomes its valence shell. And this valence shell is completely full with 8 electrons, as opposed to this chlorine's valence shell, or this chlorine's valence shell, which only has 7. And that's the reason why chlorine also wants to gain an electron. The most efficient way for it to gain an electron, or for it to reach its full valence shell, is by gaining an electron. So here, sodium and chlorine are very helpful for each other. They're helping each other achieve each other's purpose so easily. All the sodium has to do is give its electron to the chlorine, and then they can both achieve their purpose in life. So here's a summary of everything that we've learned. So ionic bonds, every time you think of ionic bonds, you should think of a transfer of electron. But generally, ionic bonds are just bonds that connect a metal and a nonmetal. So if you ever see a metal connected to any sort of nonmetal, it's an ionic bond. Like, for example, as we used in this, sodium chloride, or Na and Cl. Now, ionic bonding only happens because of electronegativity. And electronegativity is how badly an atom wants an electron. Now, you remember metals always have low electronegativity, or they don't want electrons, and nonmetals always have high electronegativity, or they do want electrons. And metals always donate an electron to the nonmetal. So in this case, it was sodium donated an electron to the chlorine. And they gain opposite charges, and they stick together. So sodium becomes positive, and chlorine becomes negative, so they stick together, because opposites attract. I hope this helped you, and I hope you now have a better understanding of ionic bonding.